and space, there are so many planets. Right now we have 8 planets, and with the sun, this is the Mercury, Venus, Earth, Moon. Moon is a natural satellite of Earth. Mars, Jupiter, Saturn, Uranus, and Neptune. And the last one, Pluto. But right now, Pluto, we are not taking a Pluto as a planet. We will make a simulator out of these 8 planets. So, before you start the code, I have also sent some details of images of planets through the mail. I hope you will get my mail and downloads, and you have already downloaded the images and sprites all of the regarding this planet. So I will show you some informations about the planets, the size of planets in our solar system. Each planet have a different size. If we take as a Earth, Mercury, this is the size of the Mercury is 38% the size of the Earth. Mars, Mars is, you can say, Mars is the red planet and is the 53% the size of Earth. I'm talking to this information because you need this information for making a simulator, making a project. So you need to understand what is the role of this information for today workshop. So Venus is the 95% the size of the Earth, very similar to size of Earth, just if we can say. After that, the Neptune is 388% the size of Earth. It's exactly the 3.5 times the size of Earth. Uranus, 400% the size of Earth. Exactly the 4 times the size of the Earth. Saturn, 945% the size of Earth. And one of the largest planets in our solar system is Jupiter. Is exactly 1120% the size of Earth, exactly the near the 10 times the size of Earth. So this is the information, and another information I'll show you. This is our solar system, and this is the time taken to the planet to cover one rotations of the sun. The Earth takes 365 days. The Mercury takes 88 days. Okay. Hmm. Okay, so if I'm audible, say yes. My boss is right. Is the vice is the voice is the right? Hello. Say yes. Okay. So Mercury. I'm talking about the Mars. The Earth is 365 days, 88 days, and the Mars is 687 days to uh, take the rotation of Sun. 687 days to the fun rotations, and exactly the Venus for 224 7 days to 24 years 7 days. So 119 years. Uranus is 84 years. Saturn is 29 5 years, and the Neptune is 164,8 years. So this is the information we need to make the simulator. And the last one is size of Earth, fast orbit. Okay, this is the same information which I talked earlier. So jump to uh, we have to make this type of simulator, real simulator. So you can see the sun is on the left side. Actually, the sun is in the center of the solar system. and all the planets are revolving around the sun. So we have to take how many sprites? We have to take one backdrop, that is based on space backdrop, sun backdrop, worst the sun sprite. We have to take how many sprite? The sun sprite first, second Mercury sprite, third Venus sprite, fourth the Earth sprite, fifth the Mars sprite, sixth the Jupiter sprite, the seventh Saturn sprite, the seventh the Uranus sprite, and eighth the Neptune sprite. So I have already sent to the mail and all of the sprite on that particular mail. So I hope you have downloaded that mail. So let's jump into the Scratch interface and just delete this sprite, cat sprite, and go to the backdrop and take a space backdrop first. That's okay. So this is the backdrop. We have to be take this backdrop like this. Okay. And the code of this backdrop is when the green flag clicked, when the green flag clicked, switch backdrop to space backdrop. Pooja Jain, I have not received the mail. Okay, so I think you have not registered form, but you can, okay, just type your email ID so I can send to you. Just give me your email ID, I can send to you. You can give me your mail ID so I can send to your mail. Okay, you are not okay, just switch backdrop to space backdrop. Okay, so okay, no problem. So let me start with the coding. This is the coding. So this is the switch backdrop to space backdrop, and you can download it this space backdrop from the Google. It's very easily you can find it. So once I click this, if I click this, the backdrop is switched to this stars backdrop. After that, we have to take one sprite. First of all, we have to be a sun backdrop, and sun is in center. So take the sun, and the size of sun is very big, so you have to take size of sun is 35. Okay, and the when when the backdrop switch to space backdrop, the position of this space, the position of this sun is in go to x negative of 3 and the position of y is 0. So the sun is in the center of the stage. The sun is in the center of the stage. Once I code for the sun, the next sprite will take as a I'll just cross this uh, Mercury. So you can see there is no sprite of Mercury in our Scratch gallery. So you have to take the sprite from the internet. I will show you the website where you can download the different sprite. The the website is the PNG ag. Okay, so you can type out any sprite, you can find it here. So this is the one of the very best website to find out the different sprite. Okay, like Mercury. So Mercury, click. So there is a lot of Mercury pictures, PNG pictures. You can find it here. And Puja, you can download it from here if you want to continue. So I have already downloaded, so just leave this. I will also give the description of this website in description box of this video. Do not worry. So just go back and take upload sprite, and I have to take Mercury sprite. Okay, the Mercury sprite is very big, so we have to change the size according to our stage. I'm taking the sprite, actually I'm taking the size of sprite according to the earth. So right now I'm taking the sprite is the 8 size of 8. Okay, 6 8. So once I upload the sprite, I have to code the Mercury. So when switch backdrop to space backdrop, okay, so when backdrop to space backdrop, the size, the position of this Mercury is negative 35 and y equal to 0. And you have to make pan down. So go to extension, take pan down, set pen color to blue, pan down, and point in directions. Go to the motions, and point in direction is 180. Okay, 180. Okay. And I want to this sprite, this planet, to rotate and revolve around the sun. So it's rotating pointing direction, and if you want to revolve around the sun, you have to be take uh, move how many steps? Two steps, and you have to be take anti-clockwise turn 3.75, and to continue motion you have to be fix this forever. Okay, so let's start. You can see our Mercury is revolving and rotating also 180 degree and around the sun, and this is the orbit of this blue color, blue line, blue circle is the orbit of Mercury. So anyone can easily find this is the orbit of Mercury. Similarly, so I hope you can uh, understand what I'm going here. Say yes if you are not. If you have any problem, to you can say. Otherwise, we will resume the session. If you have problem, say yes or type R to resume the session. Any problem regarding this code? What is the function? What is the role of pen color? What is the role of point in direction, move, turn? This script is for the location of this planet. This is the color for the orbit, circle orbit. This is the direction of the sun, and this is the move two steps to turn 3.75 degree for revolving around the sun. Okay, so now come to after Mercury. After Mercury, just come with our Venus, that is a star, a bright star. Venus is also called as a bright star. So come to Venus. We have to take another sprite, Venus. Okay, so the size of Venus is very big, but we have to be set according our stage. Venus, I'm taking the size of Venus is as 16. So when the same code was little bit change, it's the same. When I space backdrop, go to, just go to -50 and y equal to 0. Set pen color to, there is a little bit. Okay, so pen down, point in direction. Point in direction is always 180. Go to the forever, and we need to move 2.5 steps. Why we are taking 2.5, not 2? in Mercury we are taking 2 steps, but in Venus we are taking 2.5. Why? Can anyone can tell me? And the turn should be anti-clockwise around 3 degree. Okay, so let's come to fast orbit. Okay, come to this. The size of Venus is 95 size of Earth, percent size of Earth, and the Mercury is 38% the size of Earth. And it takes most fast in comparison to Mercury. Mercury takes 87 days, but the Venus takes 224 days. So we need to take something higher than Mercury. So that is I'm taking 2.5 steps, 3 degree. Now stop is all. Okay, so leave it. I will fix this at the last of this workshop. So it was only you can understand how this go all planets are revolving. And for this, we have to take pen up. Okay, is all pen up. Okay, so similarly, we have to be take pen up. Okay. So I think you can understand all of the planets here. So let's come to another planet. So let me cross. Let's not upload straight. And the third one is the Earth. I'm taking this. I am taking the size of Earth is 17. Okay, and the size of Earth is very big than Mercury and Venus, and it takes some bigger orbit. So let's go to the when backdrop switches to star space backdrop. Uh, Erase all. Wait. Erase all. Okay. So go to Earth and I'm taking the go to X is equal to -70 and Y is always equal to 0. that is in green color, blue color, sorry, green color. And down, another block is point in direction 180 degree, and move 2.5 steps and turn should be, I think, 2 degree, and the last we have to fix forever. So I think it looks very pretty, and through these observations you can understand how this solar system works. It helps to understand mathematics, it helps to understand the science behind the space, and it helps to understand the coding skills to how to make this. So I think we have done with Sun, Mercury, Venus, Earth. So after Earth, we are not taking on a moon, we have jumped directly to the Mars. Mars is very near the Earth, and the size of Mars is very small in comparison to Earth, and is a little bit something smaller than comparison to Mercury. So I'm taking the size of Mars. Let me go with Mars. The size of Mars should be, I think, 13. Okay. So I have done the uploading of the Mars. Now we have to give code script to the Mars. I think this is the 90 degree. So let me go to event. When the backdrop switches to space backdrop, and first of all, let's set the position of this planet. Go to -90 and y equal to 0, and the same process we have to be follow, that is append, set pen to color. I think this is the red planet, so you have to be take red, pen down, go to the point in direction 180, and we have to move 2.5 steps, and the last return 1.6 degree. Okay, I think the size of Earth is very big, so I have to be take size of Earth is something 15. You can calculate your size ratio of size from each of the planet. You can calculate your own. This is my calculation, but I'm something uh, going to some taking a mistakes. Okay, so no problem. Let's resume our program. Let's take pan up, pan up. Okay, okay. Actually, there is a problem. We have to be fix all of a planet in the particular stage. So maybe some variations in the constant context of size maybe differ, but you can calculate your own ratio. I think you can do better. So can you give me attendance, Pooja Jain, one of the person I have seen here, the other two one, who are they and which country does you represent? And I want to know, I think you just are you enjoying this session or not, so I can improve myself. So I hope you understand this session up to now, up to the Mars, and I have done with the four planet and the three planet left. So just come with the next planet. Which planet? Mars and the Jupiter. Okay. So Jupiter is the one of the largest planet in our solar system. So the Earth, I think its size should be 12. That's fine. 50. Okay, so let's take on a Jupiter. Okay, sorry. Upload sprite. Jupiter. Where's Jupiter? Okay, this is the Jupiter. And the size of this Jupiter, I think it should be 17. Maybe 615. Okay, that's fine. So I have done with the size of this Jupiter. Let's do with some code. Same. You can copy this code or can duplicate. Okay, leave it this. Now events, go to events and get events and drop to switch the space backdrop. Pan up. Okay, pan up. Now go to, okay, so what position should I mention here? Can anyone guess what is the position of X? You know the by is always 0. In this position by is always 0. But Can you give some idea what position of X should we mention here for Jupiter? Can notice this is the Mercury for X minus 35, minus 50, minus 17, minus 19. So the value of X are decreasing, minus 110. uh, yes, so you can see the value of X are decreasing when you are going up. The value of X is decreasing, so the Jupiter is above from uh, the planet, the three planet. So maybe the position of Jupiter is very less in comparison of these four planets. So it should be less than minus 90. So then minus 110. Let's check with minus 110. Okay, yeah, it's fine. Take minus 150. So I think we taking minus 110. It's fine. Okay, so that's fine. Thank you, Miss Pooja. Thank you for helping me. Uh, okay, so pen up, go to x minus 10, and y is always 0 because the coordinate of y is always 0 in this project, in this scenario. So go to the pen up, go to x, and similarly, this couple of code, the same couple of code, set pen color to Jupiter. Is actually the Jupiter is the planet of gases. So I have to take some color which is related to some gas. That's fine. Uh, which color should is right for the gas? I think this color. Yes, I think this fine. Okay, so this sky blue color. So pen down and in point in direction. The sprite should be in point in direction 180. Okay, so the another question is coming. What? How many stacks? Can anyone give answer? How many step? 2.5, 2.5, 2.5. Mercury 2 steps. So Jupiter, how many steps? Is it greater than 2.5 or less than 2.5 or 2.5? Where's our image? The fast orbit, the Jupiter. 29,000 miles per hour. It's greater than, sorry, it's 29,036 miles per hour. Period of 11 years. It's 13 kilometer. How is 13 kilometers? or 29 kilometers. Okay, so I think we have to take something less than 2. So I'm taking, not exactly, not sure, but I'm taking as 1.7 steps. And and turn 3.3 to 1.6, so that is greater than, less than 1.6, 1 point, yeah, 1. uh, let's, okay, okay, that is a problem. 1.7 is very low. It's 1.7. I think 10.95. 1 is a wrong answer. Yeah, there is a problem because there is a minus 150. I think there is a problem. I think so. I think that is a very big. Hmm, 1. Okay, the side should be 30. 30 is very big size. So 110. The size should be 170. Okay, it's fine. So this is the fine. I think there is a glitch, but no problem. You can decrease the size also. One. Okay. Okay, so after that, the next planet is Saturn. Okay, this is the final code of this here. Saturn, go to the Saturn. The size of Saturn is 23, and so similarly go to backdrop, space backdrop. pan up. Now go to mm, minus 125 and y should be 0. Sweat pen color to something very like this. Pen down and you have to be take move a little bit faster, 1.9, and turn should be 0.9. Wait. Okay, point in direction. I forgot this. Point in direction. Point in direction 180. Point in direction 180. Oh, please. Okay. So you can see all the planets are revolving around the sun very perfectly, very accurately. You can see it here. If you have any problem, say yes. Okay, another one, the Uranus. Okay, before that, I want to see something very really cool. Uh, one of my project is based on this English language grammar system, or you can see my channel. So once you report is right, next planet is Uranus. Where is the Uranus? This is the Uranus. Okay, so the size of Uranus should be 21. Okay, so when space, oh, sorry, when the backdrop switches to space backdrop, go to the pan up. Go to x is equal to maybe minus how much is x should we have? Can anyone tell me? Of for Uranus. What value of x should I type it here in this small pretty box? So the value of x should be minus 140 and set color to something very blue, pan down. The next is the same code, point in direction 180, and how many steps should we type it here for Uranus? 1.7, and the turn is around 0.7. Okay, so let's take this. So I hope you can understand what we are going here. The Mercury is so rotating fast and evolving fast. I want to show someone project in between this, and I was working. If you have any problem, just say yes or type R to resume this workshop. So let me, this is the one of the my favorite topic. See. So the rules of English, okay. Homophones, verbs, part of speech, text, so much as the training practical. Homophones, verbs, go to verbs. Type 1 to start. 1. I go to the park every Sunday. Option 1, 2. What option should we like this? Option 2, present definite tense. So it's very good project I'm making on this. So maybe I will inform soon about this workshop, how to make, how to rules of names. So just go back to our project. So point in direction is for rotation. I don't understand what are you talking about. Point in direction is for rotation. Pooja Jain, I'm not understanding. Point in direction is for rotation. No, 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 no. Point in direction is for not rotation. Pointing direction is the, like, see, uh, okay, suppose, let me take one sprite, this arrow. Okay, so just concentrate on this arrow. The point of this direction of this arrow is 90 degree. If I change, or I can change into two ways. First, I can change like this, 180. See, the point in direction is 180. Or like, see, point in direction 180 minus 90, 0, or 180. So this is the point in direction. Point in direction is which the sprite will face on particular side. So I hope you can clear. So let's resume our topic. Now last one for Saturn, sorry, Neptune. Where is Neptune? This is the Neptune. Okay. So the size of Neptune is 20. Okay, we add spinning to the planets. Yes. Yeah, you can spinning your planet, but in a 2D view, not 3D view, because these are the images. So backdrop, to switch to backdrop one. Sorry, space backdrop. Fan up. Go to, this is, go to means this is the position. The uh, I want this position of this planet. So I don't want here. I don't want here. I don't want here. I want here. Okay. Where's the position? 147. Or I want to this. This is the position. So see, I want this position. When I click green flag, the position, the this planet starts from here, anti-clockwise. So the buy is always like 0. Okay, and minus 155. So minus 155 and 0. So set pen color to something really tool is real one, and pen down, and point in direction 180 degree. Okay. Now come with this steps. So we have to take 1.7 steps and turn by 0.62, and the last code of workshop is whatever. Let's, so Okay, so this is our workshop of Scratch Space Simulator, and I hope you can understand how this sprite moves, revolve around the sun, what kind of movement should we give so the planets looks similarly as a rotation, and I hope you enjoyed the lesson. And one of the same project this, and if I load from as one of this dice simulator, so in this simulator you can uh, this is this dice simulator is related with the mathematics frequency and class 12 project or 11th project reset. So if you want to experimental frequency, type your typeface 3, so 0, so, and load from scratch water cycle project. This is the scratch water cycle project. This project is also understand how the water cycle works. You can found the video in my YouTube channel. So this is my channel, and I'm also making some content related with the robotics. This is the playlist. The scientist and ISO live science simulations, play maths with scratch. Please, sorry, kindly subscribe me for. So if you have any problem about this project, this workshop, just give me a question, then I can help you. Okay, so kindly subscribe me. I will help you make something very cool project. If you have any idea, just comment me. I will try to make this. If you have an idea, if you want something very special project, special rare, something simulator or something special game, so I can make it here, and just give you some tutorial how to make it. A lot of projects. You can easily find a lot of projects here. Currently, I'm working with the robotics, Tinkercad circuits made easy. My series Tinkercad circuits made easy. You can subscribe it and and just uh, see how the Tinkercad circuits work. This is a special type of robotics which we do not use any physical component. So this is the Scratch activity, rounding number of tens, place value, how to make clocks in Scratch. So many projects. Okay, if you have not any questions, so I will shut down this workshop, and I hope you will enjoy this workshop very well. Should I shut down this workshop? Okay, thank you.